Hello students, in continuation with our discussion on assertion and reasoning series, we'll today take up questions on magnetic effect of current and magnetism. In our previous discussions we have done, in first one we have discussed how we should attempt assertion and reasoning type questions there. In second one we have discussed assertion and reasoning questions on electrostatics, and in the next one we have discussed questions on current electricity. So today we are going to discuss questions on magnetic effect of current and magnetism. Let's take first question here, and of course here we'll just check the options which are there. First one is assertion and reason both are correct statement, and reason is the correct explanation of assertion. Second one is assertion and reason both are correct statement, but reason is not the correct explanation of assertion. Third one is assertion is correct statement, but reason is wrong statement. And the fourth one is assertion is wrong statement, but reason is correct statement. For all assertion and reasoning type questions, if for individual questions options are given, do go through the assertion or different options there, out of which you have to select the correct one. And only after that you go for the assertion reasoning statement and decide their status, whether they are true or false, and which one is the correct option for that particular question. So here, after reading out or checking the different options there, now let's go to the assertion statement. The energy of a charged particle moving in a uniform magnetic field remains constant. And the reason is given that work done by magnetic field on the charge is 0. Now, if you see, if a charged particle is moving in uniform magnetic field, the velocity, if you consider, and the magnetic field, they will give you the direction of the force which will be perpendicular to them, that is F will be given as your V cross B. Now here, this force will be perpendicular to the plane containing V and B. So F is always perpendicular to the velocity there. And if the force is perpendicular to the velocity, that means there is no work done by it. So that means if you consider that there is no work being done, obviously in this particular case, energy of the system will remain constant. So this is true. And the second one is that work done by magnetic field on the charge is 0. This is also a correct statement, because we have said that as the work done is 0, that is why the energy of the system will remain constant there. There is no change in its energy. So again here, assertion and reason, we have seen their status, it is true. So let's now just read out once again assertion and reason. Like the energy of a charged particle moving in a uniform magnetic field remains constant because work done by the magnetic field on the charge is 0. So it is explaining it correctly that why the energy should remain constant there. This gives the first option as the correct one. Let's take now the second question. Again, it is the same options there. Now here, assertion is that an electron and a proton moving with same velocity enters a magnetic field. The force experienced by the proton is more than the force experienced by electron. If you consider the force experienced by the charged particle which is moving in magnetic field, the expression is your F equals to QV cross B. Now here, proton and electrons both have the same charge. They are moving also with the same velocity. So obviously, if you consider the force experienced in magnitude, it will be same, because Q is same, V is same, they are entering in the same magnetic field. So in that case, B is also same. So that means if it is said that protons will experience more force than electron, so this is a false statement. And the second one is that mass of proton is more than mass of the electron. This is true because proton is about 1840 times heavier than that of the electron. So it means here assertion is false, reason is true. So it is the fourth option which is the correct one. Let's take third question. Upper wire shown in the figure is fixed. At a certain distance x, lower wire can remain in equilibrium. And the reason is given that above equilibrium of lower wire is the stable equilibrium. Okay, let's first of all take what is given in the statement part of assertion. It is given that you have one wire which is fixed and you have the second wire. It is at certain distance, say x. It is said that it can remain in equilibrium. Now the two wires are carrying current in the same direction. That means the force is attractive. If the force is attractive, it will experience force in this direction. So the second wire's weight, which will be acting downward, may be balanced by the force which is acting due to the current flowing in the two wires here. So if the magnitude of the two becomes equal, in that case it can be in the equilibrium position. So that means this is true. Let's take the second one. The above equilibrium of the lower wire is a stable equilibrium. Now, what do you mean by a stable equilibrium? If you consider a stable equilibrium, that means if a body is disturbed from its equilibrium position and after displacing it slightly from that position, if it comes back to that position, in that case we say that it is in a stable equilibrium. So here you just imagine, in this particular case, it is being balanced by the force of magnetism and the weight. Now, how much will be the force of the due to magnetic field produced by the first wire on the position of the second wire? This is your mu naught I1 I2 divided by 2 pi d into L. L we are taking as the length of the wire. So force per unit length for this wire, if you take, it will be your Fm by L, which is your mu naught I1 I2 divided by 2 pi d. If you slightly disturb from its position, that means suppose it is d is increased, then this F will decrease. And the weight which is acting downward, that one will be giving a net force on the body. So in that case, the body will get or the wire will get further disturbed from that position and will never come back. Remember, in which case it will try to come back to the equilibrium position there. If the force which is acting, net force which is acting, is directed towards the mean position or equilibrium position. Here it is restoring force type thing is not acting there. So obviously in that case it cannot come back to the mean position. That means it will not be in stable equilibrium. So that means it is false. So here assertion is true, but reason is false. That means the third one is the correct option. Let's take next question. Again, the options are same. Assertion and is correct. Reason is false. That is the third one. Fourth one is assertion false, reason true. That is the fourth one. Torque on a coil is maximum when it is suspended radially in a magnetic field. Yes, torque if I take, suppose on a coil, in that case it is how much? It is your Ni A cross B. This is the torque there. And here, if the field is acting radially there, in that case the angle between the vector area and magnetic field, that one will be 90, and in that case this will be maximum because it is your AB sine 90. So in that case you will give the maximum value. That means it is true. And the reason is given that the torque tends to rotate a coil. This is also true. But let's now take assertion and reason together. Torque on a coil is maximum when it is suspended radially in a magnetic field, because torque tends to rotate a coil. This does not make any sense there to explain the assertion there. So obviously the second one will be the correct option. Both are true, but reason is not the correct explanation for the assertion. Let's take the next question. Again, it is the same options. So we take the assertion. Galvanometer to ammeter conversion take place by connecting a low resistance in parallel with it. That's correct. Galvanometer, if you consider, when we connect a low resistance shunt in parallel with this, then we can convert it to an ammeter of suitable range. Because here, if you consider that you want to increase the range, in that case, whatever extra current or maximum current which is going, they will pass through the shunt and galvanometer current will remain within its maximum limit. So we can connect it to low resistance there in parallel with it. That is true. And why we are connecting in parallel also? Because if you are connecting in parallel, the net resistance or effective resistance of the ammeter will be less. And if it is less, then in that case, the current which is measured there will be more accurate. Reason is the low value resistance increases the effective resistance and protects the galvanometer. It is protecting galvanometer, that part is okay because it is bypassing the current there. But it is not increasing the resistance, effective resistance. This is false. Because if the two resistances are connected in parallel, the effective value or equivalent resistance will have a value less than the individual resistance of the two resistors there. So that means here assertion is true, reason is false. So that means third one is the correct option. Next, if an electron is not deflected when moving through a certain region of space, then the only possibility is that no magnetic field is present in that region. If you have an electron or any charged particle, if it is moving in the region of magnetic field, in that case, the force which is acting, it is given by this expression F is equals to QV cross B. And here in this case, you can see if B is 0, then definitely force will be 0. But that is not the only possibility. If the charged particle is moving in the direction of magnetic field, then also the force will be 0. So that means this is false. Next, reason is force on electron is directly proportional to the strength of the magnetic field. This is true because we have seen here force will be QV cross B. So if the force is QV cross B, that means it depends upon the magnitude of the magnetic field apart from its magnitude of the charge as well as its velocity. So that means this is also true. So now assertion is false, reason is true. That means the fourth one is the correct option. Let's take the next one. Again, same set of options are there. Assertion is if a charged particle is projected in a region where B is perpendicular to the velocity of projection, the net force acting on the particle is independent of its mass. Now here, if you consider the force on a charged particle, we have already discussed this. F is equals to QV cross B. If the charged particle is projected in the region of magnetic field and the B is perpendicular to the velocity of projection, that means in that particular case, F will be equals to QVB sine pi by 2. That means it is only QVB. The net force on the charged particle is independent of its mass. This does not depend upon the mass of the charged particle. It will depend upon the velocity, it will depend upon the charge, it will depend upon the magnitude of the magnetic field. Apart from that, the angle between the two, but once it is said that they are in the same, they are mutually perpendicular, in that case, here that sine theta term will be 1, and we can say that if it is said that it is independent of mass, that means it is true. Next, the particle is performing uniform circular motion and the force acting on it is mv square by r. Now here, if you consider that this particular case, obviously if the V and B are mutually perpendicular, definitely the force will be acting in a direction perpendicular to V and B. Both it will describe a circular path. And its magnitude is your mv square by r. This is also true. But now let's read the statement altogether. If a charged particle is projected in a region where B is perpendicular to the velocity of projection, then the net force acting on the particle is independent of its mass, because the particle is performing uniform circular motion and the force on it is mv square by r. This is not explaining the first part, that net force will be independent of the mass. So obviously in this case, it is the second one which is correct. Assertion is true, reason is true, but reason is not the correct explanation for assertion. So here the second one will be the correct option. Let's take now 8th question. The magnetic field configuration with 3 poles is not possible. Of course, you know that in magnetism, monopoles do not exist. Whenever magnetic poles will occur, they will always occur in pair. So obviously with 3 poles, magnetic field configuration is not possible. This is true. No torque acts on a bar magnet itself due to its own field. This is also true. A bar magnet will not experience any torque due to its own field. It can produce torque on any other magnetic dipole or any other bar magnet which is there in its field. It can exert torque on that, but it will not experience torque due to its own magnetic field. So obviously this is also true. Now let's read out the statement again. The magnetic field configuration with 3 poles is not possible because no torque acts on a bar magnet itself due to its own field. So it is not explaining the assertion or statement there. So obviously both are true, but it is not the correct explanation. So second one will be the correct option. Now let's take the next question. The basic difference between magnetic lines of force and electric lines of force is electric lines of forces are discontinuous and magnetic lines of forces are continuous. You know that electric lines of forces will originate from positive charge, they will terminate on negative. So in that context, we can say that they are discontinuous. But when you take magnetic lines of force, they are continuous, because if you consider that you have the north pole, south pole of a magnet, magnetic lines of force will originate from north pole, terminate on south, but inside the magnet also it will move. So it will form a closed loop there. So that is why we say that they are continuous. So in that case, this is true. And magnetic lines of force exist in a magnet, but no electric lines of force exist in a charged body. This is also true. So now let's just see the assertion and reason together. The basic difference between magnetic lines of force and electric lines of force is electric lines of forces are discontinuous and magnetic lines of forces are continuous, because magnetic lines of forces exist in a magnet, but no electric lines of force exist inside a charged body. So that means it is explaining it correctly why they are discontinuous there for electric lines of forces and why it is continuous for magnetic lines of forces properly. So the first one is the correct option. Let's take the next question. Magnetic field cannot change kinetic energy of a moving charge. Again, you know that force expression, it was your Q V cross B. Force is perpendicular to the velocity and magnetic field. And if the force is perpendicular to the velocity, definitely there will be no work done. And if no work is being done, that means no change in the kinetic energy. So this is true. Magnetic lines of force cannot change velocity vector. Now here you see, if the charged particle is moving magnetic field, in that case what will happen? It will describe a circular path. And if it is describing a circular path, if the velocity, if you consider, it will be acting tangentially there, at every point there. So as it is acting tangentially at every point, it is basically changing the velocity vector. So if I say that it cannot change, this is false. So obviously here in this case assertion is true, reason is false. That means this is the third option, which is correct one.